Hey guys, welcome to the Ericsson HeadSpin webinar. I'm Rajiv Bhutani, I'm the CEO of HeadSpin. In today's webinar, we will cover the partnership that HeadSpin has established with Ericsson. We will showcase the joint offering we've developed around the 5G and edge computing space. And we also share with you a few case studies along with the overall value proposition that we are jointly trying to drive in the market. For today's webinar, I'm joined by Leandro, Raj, and Per from the Ericsson team, and also Brian and Rajiv Ranjan from the HeadSpin team. If you go to the next slide, Leandro will cover the challenge or the opportunity along with our partnership. I will share a few points around our HeadSpin and introduce our platform. Per, Raj, and Brian will showcase our platform in action, and then Rajiv will talk about the customer success stories and unique value proposition. We've also kept time at the end of the session for Q&A, and we'd love to engage with you. So with this, I'll pass it on to Leandro for taking us off and starting us off with the first two topics. Over to you, Leandro.
Hello, everybody. My name is Leandro Montesioca, and I'm here to give you and present to you introduce the 5G opportunity and what we are doing. If you go to the next slide, please. So the 5G opportunity is a big opportunity, an unprecedented opportunity, but for the whole industry, not only for CSPs or operators. If you go to the Ericsson Mobility Report that you can download from the Ericsson.com page, you see that we estimate for network providers is a $3.7 trillion opportunity, and for the whole industry, the total expected revenue out of this is 31 trillion, right? And how are we going to do all this money? So basically, there are some different use cases that 5G per se, this technology enables, right? First of all, everybody's looking about gaming latency from 1 millisecond and bring it to games around 10 milliseconds will help us also to get all this new gaming user experience that the media and the people are expecting. We see also in autonomous vehicles with 5G, we are the first time that technically wise, we are able to, the response time is better than the human response time. So we can go 40 times quicker on the response time as a normal human being. So that enables us the possibility to get into the autonomous vehicles. We see also fixed wireless access. So we can see multiply by 10 the download and the latency that we can get by normal Wi-Fi connections that we get at home. We see also immersive experiences by enabling with this virtual reality and augmented reality, as 5G will enable all these use cases in order to be ready for 5G. We see also beyond visual line of sight networks that can control remotely different drones and different networks in order to provide goods from A to B, where it's controlled by the network with no human interactions. And last but not least, we see also the remote medical assistance possibilities, where this latency you can do that not only assistance, but also even remote surgery using different robots and having talent people not all around the places, but in one place and remotely serving all the different patients that you have in different parts of the world, right? Next slide, please. Yes. Why are we doing this with HeadSpin? And the HeadSpin partnership is threefold. It's basically we are as Ericsson and investing in the company because we believe in the platform, we believe in the solutions, and that HeadSpin is bringing to the market. We have a global frame agreement to provide all those solutions together to the market, to our customers, right, on a global basis. And the third leg, and I think the most important, is that we are working together on our technology partnership in order to secure, optimize the solutions that HeadSpin and Ericsson brings together from today and develop solutions for the future. And by saying that, I would like to get it back to you, Rajiv, to continue. Thank you so much.
Yeah, thank you, Leandro. Tina, if you could go to the next slide, that'd be great. Yeah, so thank you, Leandro. We're very proud of the partnership with Ericsson and the joint aspiration we are driving in the 5G space. So with regards to introduction to HeadSpin, I'll cover 3 points. I'll share with you all our mission and why it's important. I'll talk about the core elements of our platform, and then I'll also share with you all a few industries that have already adopted our platform and are starting to see and derive value from it. With regards to our mission, as you see on the slide, our goal is to make every digital experience flawless. As Leandro mentioned earlier on the slide, 5G, along with edge computing, is providing a completely new environment for companies to innovate. The download speeds will be 100 times better than the cellular networks. Latency will improve by over 10x, and then this infrastructure will allow connectivity across millions of devices. Whether you're a CTO or CIO organization, each of these groups are starting to plan or create applications that are leveraging the advancements in edge compute and 5G to transform how they're running their business. We expect that majority of the data will be generated and processed at the edge in the coming years. And when that happens, the developers will need to optimize a combination of networks, computing technologies, as well as a host of endpoints to ensure that they can take advantage of 5G and edge applications. This environment will also require a fresh set of tools. And given that 5G and edge compute is very localized, they will need to have efficient ways in which they can test this infrastructure during the development process, and as well as post live, to understand how the experience is manifesting itself and whether the promise is being delivered. That's where HeadSpin comes in. So Tina, can you go to the next slide, please? We've created a platform that combines real world edge infrastructure along with data science, and it provides a developer tool for engineers or network providers to develop 5G applications. There are 4 elements to our platform. I'll talk about the ones which are in orange. The first one is our patented hardware that contains real devices that can be deployed at the edge. Now, we cover a range of screen and screenless devices, and these devices could be deployed anywhere in the world as long as there is stable power and stable internet. Second is, once these devices are deployed, our platform makes them remotely available to global teams who can use them to test 5G-enabled applications. These could be traditional applications or immersive applications, just like how they would if they were at the location and holding the device in the hand. Thirdly, our data science platform, which is quite extensive, will automatically identify the poor experience areas. They will analyze what's causing the issues, and they will provide recommendations on changes that need to be done to the applications or the infrastructure so that the experiences could be improved and one could achieve flawless experiences. And then lastly, because there is a ton of data that we're generating, we've created a way in which all of this data could be easily accessed either for alerting purposes or integration into their existing systems, or for that matter, onboarding into any of the dashboards that have been used for measuring during the engineering, as well as for measuring the post-release process. Go to the next slide, Tina. Our platform is being used by a number of industries today. We are seeing significant adoption from digital natives, as you can see, from telco, gaming, media companies, and also manufacturing and auto companies. Each of these companies have used our platform today to drive significant improvement in the product quality. They have improved the time to market. They've improved the CSAT, and then ultimately they've improved their revenue. So we are pretty excited to show you the platform. I'm going to pass it on to Per, who can take you to the demo and then show the platform along with Brian and Raj. So Per, over to you.
Actually, I think if you can move to the next slide, it's actually Raj here.
Okay, Raj, please go.
Okay. Thanks, Rajiv. So in this next section, what we're going to do is give you an insight into how we've infused HeadSpin functionality into the Ericsson portfolio to sort of enable successful 5G transformations, and then also give you a flavor of some of the key use cases which are enabled through this collaboration that we're bringing to market here. So fundamentally in this slide, we're outlining key elements of the portfolio. So the first one here is Ericsson Automated Remote Testing. This enables customers to test their devices and applications with real network infrastructure with the latest features using automated remote capabilities. Through this environment, customers can virtually view, control, and configure the device and the test to quantify its performance on different mobile network configurations. The second component that we've integrated HeadSpin into is our Ericsson Device Analytics solution. And EDA provides real-time network performance from devices at any place in the world at any time. It measures critical KPIs. Examples of those critical KPIs that we measure include signal strength, throughput, namely downlink, uplink, and latency. EDA supports both standalone and non-standalone 5G functionality. It's supported on Android devices and can be embedded into IoT devices, such as next generation 5G Cradlepoint routers, such as the R1900. The other portfolio element in which we've integrated HeadSpin is our Ericsson Connected Vehicle Testing solution. And this provides a full suite of connected autonomous vehicle quality assurance services, which support both pre-launch and post-launch. And examples of the portfolio include TCU testing, cybersecurity testing, and testing on live networks using 5G test tracks. As part of this portfolio, we do application testing and infotainment testing on the head-end unit, and this functionality makes use of the HeadSpin platform integrated into our connected vehicle testing environment. The remote application testing makes use of the HeadSpin capabilities to remotely test the performance of applications on networks around the world using the HeadSpin points of presence. And HeadSpin has points of presence in various cities and various countries around the world. And so the key impacts associated with this offering leads to lower capex and opex by eliminating the need for building dedicated test facilities or traveling to facilities to undertake the testing and reducing downstream post-launch costs. It provides optimized application performance by correlating application KPIs with real network performance metrics, and it reduces testing lead times and increases revenue through improved customer experience, reduced churn, and it enhances competitive performance through benchmarking studies. And next slide, please. So this slide shows the various 5G use cases which are enabled through the Ericsson HeadSpin collaboration. They're depicted in sort of the graphical format you see there. The first one that we've decided to highlight is the ability to test 5G devices and applications remotely with real network infrastructure. The second one is real-time 5G network and application performance analytics. The third one is benchmarking networks, devices, and applications. And then we do drive testing of devices and applications with real-time data analytics captured. We also support benchmarking performance as a function of time for network congestion and optimization studies. So if you want to do congestion and network optimization studies. And this is all centered around optimizing the 5G user experience for different devices and applications in sort of the 5G world. So the overarching sort of value proposition associated with this is optimization of 5G devices and applications for enhanced user experience, higher net promoter scores, and reduced churn through automated remote testing capabilities supporting real-time data analytics. Okay, I think I'll hand over to Per and Brian for the demo now.
Thank you, Raj.
Thanks, Raj. So yeah, we're going to spend a couple of minutes on demonstrating how this works in real life. But before we dive into the demo, just a recap of the platforms we're about to see. So as Raj showed us earlier, the HeadSpin platform has multiple components in it. So at the top there in orange color, you'll see the HeadSpin, the platform itself, with its satellite P boxes, located across the globe in public locations, with smartphones and other devices with locally provisioned SIM cards from the service providers on location. Adding to this, we placed a number of P boxes in our own labs, so in Ericsson's R&D facilities, which it makes it possible for us to expose them to really special network conditions just for testing. So in a lab of our own, we have a number of them across the globe. We can create any sort of network condition we want. And the control mechanism behind this is the automated remote testing, which is there in the blue box. So that's the thing that controls the radio and the core to generate the conditions we want for the test, and also to execute the test cases through scripting. And then the third component, which Raj mentioned just now, is the device analytics piece, which is a piece of software, or a probe, if you will, that we install inside the smartphone, which goes into a HeadSpin T-box, which enables us to capture data on any location, and then through the device analytics analysis tool, visualize the data, and also process the data, and also cross-correlate it with other information coming from the HeadSpin platform. So the demo we're going to see will start with a run through of the automated remote testing, and then over to HeadSpin. This dashboard is the landing page after logging in, and it's from here I can initiate various types of testing, as well as to manage my tools and scripts. We have three main pillars: application testing, manual testing, which is for
Sharon, I think volume is pretty low.
Test cases, and automated testing. We'll be looking into automated testing in a moment, but before we do that, I want to show you some of the key building blocks and capabilities we use for device and application testing. So let's go to application testing and have a look at the tools. So in here, we have access to the HeadSpin devices located in the lab, and we'll see a demo of how this environment works in a moment. But I'd like to highlight two other important tools for now: the network configuration tool and the attenuator. So the network configuration tool allows us to control the thousands of parameters that define how a radio and core network behaves. We can, for instance, set timeouts, enable and disable fallback mechanisms, bandwidth allocations, maximum allowed devices in the cell, and so on, allowing us to create any network condition we want. The other one, the attenuator, is connected between the radio control nodes and the antennas, allowing us to increase and decrease signal levels coming out of the antennas. These two tools together allow us to test things like handover between cells, and when a device moves from a high bandwidth cell into a congested cell, or moving between 5G cell and a 4G cell. These tools are programmable and are used as building blocks when scripting our automated tests. So going to the automation part, let's see how this works in a real case. So this section allows me to either define my own test cases and put them together in more complex test suites, or I can simply use a predefined test suite and run as is, or change some of its parameters before running it. So the list on the left, you can see all the test suites which my user profile has access to. So I'm going to select a simple one, this one, and that brings up a list of previously run jobs based on this test suite. So I'm going to just create a new job based on the default parameters of the test suite. Apart from running it immediately, I can, of course, schedule it to run it later on. So I can set the date and a time when I want to run it. And I can also add additional executions. So if I want to run it every minute or every hour, for instance, and a certain number of executions. And I can also set conditions for repetition. So I can say that the whole suite should be run every time, or just rerun the failed test cases, for instance. But for the purpose of this exercise, I'll just go ahead and run it now, like that. So as you can see now, it initiates execution in the lab. So this test case is a fairly simple one. It sets the frequency bands to the one we want in the lab. It puts the device into flight mode. It then changes the attenuation of the radio so that the device can get a strong signal, and this mimics being close to the antenna. So as you can see, now it starts. So we'll just go into the execution and see how it progresses. So for the purpose of this demo, we actually pulled out a device and put it on the table so you can see that it actually does something. So you'll see that the screen shifts as we go in and out of flight mode, for instance. So as I mentioned, it turns off turns on flight mode and then off again. Then it checks that the device attaches to the network. It sends a ping to a server to verify the result, turns flight mode back on, and then reports the results. That's the end of the test case. It's going to take a while for this test case to execute. So in the interest of time, I'll just go back and show you the result of a previous run. So here's one, for instance. So each of the sessions, they generate a report. So this is the previous one. It passed 100%. It was just one test case, none skipped and none failed. And if I want to go into the details, I can check the logs as well. So each of the runs contains a detailed logs for the engineers to look at exactly what went on, and especially if something failed, which are the parameters set, reset, changed, what is the traffic going between the device and the network, and also within the network. So this automation machinery is focusing on controlling the device and the network. So now we'll see some more insights into how to test and evaluate the user experience by adding the application and service aspects to the test scope. And this becomes, of course, increasingly important as the 5G experience builds on low latency and service stability. So with that, I'd like to hand over to Brian, who will show us more about application testing using the HeadSpin platform in this context. Over to you, Brian.
Hi, I'm Brian Caldwell, and my presentation will show how to drive testing within the network environment set up within the Ericsson lab, both from a manual perspective and an automated perspective, and how to make use of the data collected during the test. So here in front of me, I have a device that's sitting within the Ericsson lab. On the HeadSpin platform, you can see all of your devices that are within the lab environment. You can easily open up a device to run a manual test. Within the UI, you can scan this QR code on your device in your hand, and you can actually drive, for example, multi-touch gaming and other rich interactions directly from a phone in your hand. You can also interact with the applications directly within the lab environment, as well as you can hook up the device to your automation system, and you can drive automation using WebDriver or local automation tools by running the hsconnect command to connect the device locally. As you're using the application, everything you're doing is being recorded. What we've done is we've instrumented the device in the test environment to record system information, what the user hears and sees, as well as other network and function call information. What that looks like is when you're done running your manual test, HeadSpin gives you a session recording of the complete test. So what you're able to do is scrub from the beginning to the end, and you can see where the game begins, kind of entering the game, and ultimately logging in, and then going into some gameplay, and choosing a level and starting the game. So what HeadSpin is doing is, as you're driving this test, whether it's a manual or an automated test, within the network environment, we're collecting a lot of data. So we have a section here on what the user sees on the screen, the video quality, and some of this data is applicable to different types of apps. So within a gaming space, some of the video quality is useful, but we also see that very useful within the streaming media space. We go down, we can see the frame rates, we can see the CPU statistics, the network statistics. We can see memory statistics, as well as rendering statistics, as well as energy usage as we're using the game. If I go down further, what we're able to see is network traffic coming from the game to the API server. So HeadSpin intercepts common API protocols, HTTPS, WebSockets, as well as DNS requests. We also parse out logs, so you can grab the log errors, log exceptions, as well as the metadata around which applications in the foreground. we bring this all together in a single place and annotate it. For example, we show you where there are different issues that might be affecting the user, such as loading animations and interstitials on the network side where there are slow downloads. And so this is what we're calling the session UI, which is how you see the recording of all of the data from the test. So I'd like to jump over now into what a continuous testing and data collection environment looks like within the telco test lab. So here's an example of running many tests using automation continuously. And so this is the HeadSpin platform gives you a stream of data sessions. The stream, every data session is tagged with multiple tags. The tags include the build version information, the backend version information, information about the feature flags, information about different settings that are used during the test. And typically to run monitoring in the environment and to collect data continuously involves setting up your automation and then tagging your sessions as the automation is running. So we have a continuous stream of data. And what that creates is within the HeadSpin platform is we have a lot of data points that are being measured continuously over time. So within this view, what we're seeing is every test session you ran, every dot here is an actual session that was run on a device within the network environment, running a test case that's collecting data as the end user would see it in that environment. And so you can see that we're running many tests over a long period of time, collecting a lot of data. And HeadSpin as a platform has the ability to help you aggregate the data. So we have a system called Regression Watchers, where you can actually add watchers to the data stream here. So as you're running tests continuously, you can, for example, compare today to last week. You can compare the current build version to the previous build version. And as new data streaming in, we're continuously comparing the data to find statistically significant exceptions. So where, for example, is the loading time of your application significantly higher? Where is the media quality lower? In what times or what days are you having buffering events that are sort of abnormally large? And so there are many different use cases you can use to answer these questions. And what that looks like is when you get an alert from the HeadSpin system, let me just go here, we deep link you to a UI that looks like this. And this UI gives you a deep dive into what exactly went wrong at that alert. So we show you on the left, for example, the previous build, on the right is the current build. And this is what the difference looks like between the builds. You can actually scrub and see exactly where the differences are in the builds. And as I go down, I can see where the differences are in the network traffic between the builds. I can see where the build is better in some ways and worse in some ways. And I can get a complete breakdown of all the API calls that are changing across build over build. I can get a breakdown also of the issues in the build. So for example, one build here appears to have much more blank content on the screen than the second build. And that might actually be the issue, that I should go investigate. The HeadSpin regression system is a rich language that can be set up using an API or from the UI. This is an example of setting up a comparison on your data stream of the current build versus the previous build, controlling, looking at the network latency and also focusing on a certain geography within the US. So there's many ways to set up the regressions to work for your team, but regardless of what you're trying to do, we have customers who, for example, care about application loading. We have customers who care about video performance. We have customers who care about frames per second and gaming performance and battery usage. So depending on what you're trying to do, you can set up this regression system to find issues and alert on issues proactively. This is just a very quick demo of how to use the data and the HeadSpin platform within the network test lab. Please get in touch with HeadSpin if you have any questions about setting this up, and we're happy to set you up and get you up and running. Thank you. Bye.
So the next demo that we're going to show you is one showcasing EDA and HeadSpin integration, and the demo itself will focus on the integration itself rather than the functionality of EDA or the service level KPIs you can extract with HeadSpin. Brian's already been through that. In the demo, essentially what we've done is we've downloaded the EDA onto a HeadSpin point of presence using a virtual private cloud environment. It can be done through a virtual private cloud environment or even a dedicated connection as well, if you have the setup in your lab. Essentially what this allows is it allows customers, users to correlate the application level KPIs and metrics from the HeadSpin platform with real-time network performance data using EDA, and thereby support multiple analytics and use cases for 5G. With that, can we please run the demo?
Devices tab, a specific device should be selected for the tests. EDA application should be downloaded and installed on this device. When the app is started, the connected device sends performance measurements, which are in fact the real-time geographical location correlated with radio-related and network speed test information, into a central database in the cloud. The collected data can be used as an input for optimizing the network to secure optimal quality of service. In order for the data correlation to be started, HeadSpin menu option should be tapped. At this moment, the specific HeadSpin's user API token should be known in order to be placed here. The API token is validated, and if it's OK, from this time forth, EDA app starts scanning for any active HeadSpin test instances. In the background, EDA still gathers network measurements and sends them to the cloud database. Then, in order to start the recording session, the blue button on the top right corner of HeadSpin portal should be pressed. This will take a few seconds to start. When the capturing session is finally started, then this blue button will become green. Once EDA application identifies that the session has started in the background, a relevant indication on the device screen will pop up for a few seconds. All new measurements gathered by EDA application will now be correlated with this specific session ID. Whether EDA application has identified any active sessions is presented on the relevant HeadSpin menu item. Later, in order to stop the capturing session, the same button on the top right corner of the HeadSpin portal should be pressed. And following, stop recording session. At this point, on end application screen, you may see some details regarding the previous capturing session. Those include the session ID and the start and end time of this test. This specific session ID can be copied and then used in EDA Visualizer. With EDA Visualizer, we can visualize measurement data as they are fetched from EDA database. The representation can be either 2D or 3D. The ID of the previous HeadSpin session can be pasted here. As a result, all the data gathered during this specific session will be fetched and visualized. Hovering over the measurements provides more details. This is shortly how you can correlate EDA measurement data with HeadSpin KPIs. Thank you very much for watching.
Thank you so much. We'll move on to the next slide. Tina, if you can move to the next slide. Rajiv Ranjan, over to you for taking us through some use cases and the value proposition that we are driving.
Sure, Rajiv, thanks a lot. Okay, so we are going to talk about 4 win stories here with some of our key clients in the 5G space. The first one is related to a US-based telco provider that is evaluating ultra-wideband 5G termination for home networks using HeadSpin. Now, we all know that there is massive capital investment happening in telcos from a network perspective to build out networks of high throughput and bandwidth in order to ensure flawless 5G experiences. But the return on investment on that capital that telcos are looking for is in the form of replacing existing services like companies like are providing cable services and other such things. So for example, transforming a home network into a neighborhood Wi-Fi kind of a model is what we are talking about. So the client that we are working with over here has been pretty ambitious in transforming their network experiences. And as part of that mission, what they're trying to do is they are launching this ultra 5G band to home termination, which means you can replace a cable to home setup with a neighborhood Wi-Fi setup. This is an ultra wideband setup with a massive throughput delivered through a local termination. Now, the challenge in this setup is how do you ensure that the end customer is getting a good quality service? One way is to test using field testing that is done by a set of engineers of the field. But this approach is quite time consuming and not practical, especially when you're launching in multiple locations and you need to ensure scale, which turns out to be a huge challenge. So what this client has done is they have created apartment labs in each of the cities. So it's like one of the apartments in a complex is converted into a lab to test out this ultra wideband Wi-Fi to home service. And in order to do so, HeadSpin P-Boxes, which is the HeadSpin appliance, is deployed in the lab, and phones and browsers are plugged into it. So this behaves like an edge zone setup that can be used to test out the quality of experience. So this enables distributed teams sitting in multiple locations to access this setup and the home Wi-Fi edge zone from anywhere in the world using the HeadSpin UI and do all the tests. So you can continuously access the edge zone in the apartment that is enabled using this solution. So they can validate things like how the termination is, when multiple devices communicate, then how the experiences monitor network KPIs, and also interaction amongst multiple device scenarios. The second case study that we have over here is about and probably we can go to the next slide. Yeah, so the second case study that we have here is about a MVNO. As part of their new initiative, they have to ensure that they support all popular mobile devices in their network. And they have a team that takes care of pre-release device testing that they wanted to test in an automated fashion. HeadSpin has deployed 5 HeadSpin configured appliances in multiple locations across US that has been deployed in clients' labs. And using this setup, we enable remote access to pre-released and brand new devices from offshore locations, as majority of their testers are in India, who remotely access the devices and they are able to do automation testing on these devices. Using multiple data points that HeadSpin captures, compatibility of the device is validated. And using the solution, the client has been able to cut down on the cycle time for testing, also reduce the number of resources that are working on it. Another important aspect of the solution is the field testing aspect, right? Which is using the HeadSpin reverse bridge capability. So field testers can reverse bridge the devices that are there out in the field to HeadSpin platform, and then they're able to test it out. The third one that we have here is related to a benchmarking use case, and we can move on to the next slide. So the third one that we have here is about a leading APAC-based telco provider who were looking to benchmark their network performance in the region. HeadSpin solution was deployed in multiple locations across the region. A combination of various device types was set up in HeadSpin Cloud that was used as a testing environment. Automation scripts were created covering critical user journeys across peer applications and scenarios such as streaming videos, uploading media on social media platform, downloading app, etc. These scenarios were analyzed. And using HeadSpin data and analytics platform, application and network KPIs were captured and compared using HeadSpin visualization dashboards. So this enabled the client to compare the KPIs, run regression, and keep a track of their network performance on a continuous basis. The last one that we have over here is a pretty interesting one, as it enabled deep collaboration between an ISV, telco provider, and a game streaming company. Can you please move on? Yeah, so in this particular case study, it enabled a deep collaboration between an ISV, a telco provider, and a game streaming company, and they all leveraged HeadSpin to enable flawless application experiences. While we talk about the world getting split into private edge zones and public edge zones and the promise of 5G that enables the mobile edge compute setup. So this MEC setup from a service provider like Amazon or Microsoft or Google can be deployed in a mini data center of telco. Thereby you can offer the services from the cloud provider locally in that environment. And the whole idea of this setup is to give low latency experience at the final mile to the users, which ensures high throughput at the final mile. But one thing which is to be considered here is the application also has to be deployed nearby. Therefore, telcos, ISVs, and cloud providers have come together to create this new architecture for distributing services. Telcos are providing the 5G network, mobile edge compute comes from ISVs, and then on top of that, you can deliver consumer apps and enterprise apps. Now, in this case, the telcos team has set up multiple labs across US, and across these labs, they are trying to onboard ISVs. The MEC environment setup that we're talking about has been set up in multiple labs with different ISVs, and they want to ensure that ISVs come and test out test out in this MEC lab and ensure that all the issues in this environment are solved. So, of course, ISVs can't do this type of testing physically. This is where HeadSpin solution comes into play that enables our ISV client to test out their MEC solution remotely in the telco lab. Specifically in this case, as part of the pilot, Los Angeles Airport, that is already a 5G zone for the telecom provider, was used as the testing lab. So our ISV client that provided the MEC solution was able to access this lab remotely using HeadSpin and test out the game streaming experience of 5G application. And now with a successful pilot, client is setting up HeadSpin across 3 labs in the US to test out their MEC solution. This way they can ensure that the application works very well in the combination of 5G and MEC environment setup. So these are some of the key use cases that we have implemented across various customers. Next slide, please. So I'll just quickly summarize, all the solutions that we talked about, all the discussions that we have through all our colleagues. So here are the 3 key takeaways of a solution. First is the ability to measure, validate, and continuously monitor quality of experience on the edge, which HeadSpin and Ericsson solution facilitates for you. You can have your distributed teams in multiple locations across the globe and enable them with this capability to remotely access the edge environment and run their tests. Second, the solution enables experience validation across 5G transformation. While moving from cloud-based applications to 5G applications, you can not only benchmark experience KPIs, but also get a comparative view of pre and post transformation, thereby ensuring flawless experiences across the transformation journey. And the third, which is probably the most important one, is the ability to develop a holistic evaluation of experience covering network, cloud, device, application, so you can collaborate with with all the stakeholders to deliver flawless experiences to your end users. So with that, I'll conclude the solution bit over here, and probably we can go to the Q&A part.
The first question is, what is required for succeeding in the 5G experience economy? So perhaps I'll share a few points, and then for the panel, please chime in. But if you're if you're a CSP, then in my view, for succeeding in the 5G experience economy is to go beyond connectivity and provide different types of capabilities or applications to businesses so that they can truly transform using the infrastructure. Now, these could be automation, this could be intelligence, or it could be what we have out here, providing tools that helps companies understand the experience improvement that is being done in an efficient manner and to perfect it over time, right? So I think that's one. If you're a developer, then succeeding would mean understanding what needs, how can innovation be achieved with all of this amazing infrastructure that's being deployed. But Leandro, Per, Brian, over to you all for your thoughts.
Yes, you're perfectly right, Rajiv. I mean, at the end of the day, it's about the ability to process data, to collect data first, process it, and provide value, right? I mean, we see different use cases from a 5G factory, and the ability to reduce the production rate for 1% is an enormous cost gain that you get, and an enormous. I mean, in order to be competitive, you need to get into these efficiency gains. When it comes to applications, you need to collect the data, and transform it and provide additional value, and provide, as you said, new services, right? And this is with mobile edge computing capabilities, with try to get the best use of the latency and also the response times, and also the speed that 5G provides, gives you the additional competitive advantage to others that are not incorporating those. So it's a race, and everybody's running, and you cannot stop for a second, because others will overtake you. So you need to take the chance and evolve your solution in order to get the best use of all the 5G capabilities that they're bringing in.
Another really interesting partnership that we've seen at HeadSpin is just getting on the edge and testing. It's a little bit opening up multiple backends. I think it's we're seeing a world where one application can have different backends depending on which edge it's run on, and making sure that you can actually test in those scenarios and make sure everything's working seamlessly. We've seen a lot of value in that, and validating the assumptions using data, and the simple fact of running an edge and validating this, that everything's working in the new world is something that we've seen help some of our partners.
Thank you, Brian. That's awesome. So the next question is, how will the impact of 5G compare against what we saw with 4G networks? So Leandro, Per, your thoughts?
I can take that one. So yeah, I mean, obviously it's a leap of technology between 3G and 4G, as well as between 4 and 5. So I mean, it's going to be, of course, a big impact on how you develop services. I think the leap between 3 and 4G was quite a big one, with the immense increase of bandwidth and capacity in the network that we saw then. What we're seeing now is similarly a big change in what we can expect from the networks in terms of quality, throughput, latency, and such. So that's going to have a big impact on completely new use cases. I mean, we've seen gaming, for instance, before, and we've seen the video streaming before as well, and we had video calling already in 3G. What we're seeing now is that the capacity and the capabilities are on such a high level that we can almost ignore the network, that it's so fast that it can support almost any use case. So that's going to be a big change.
Awesome. Thank you for that. The next question around the enterprises. So as an enterprise, how should we approach edge compute and 5G transformation? Brian, would you like to take this?
Yeah, I think it's been interesting to see as 5G rolls out, there's a networking side as well as a cloud side, and these two are evolving together. I think on the cloud side, we're moving to a world where we're having multiple backends. We need to move to more of a continuously deployed, frequent testing world, because the more environments you maintain, the harder it's to do anything manually. So I think 5G is really raising the level that teams need to automate their deployments. Teams need to test faster. Teams need to get used to sort of rolling things out at a larger scale. It's not about just one server anymore. It's many servers, and so I think you're seeing an evolution on the cloud side in parallel to the networking side, and I think that might be the biggest part that affects enterprises. Making sure that the architectures deployed are moving in the direction of containers and having sort of the ability to deploy continuously and test continuously. And that's where we find a lot of use cases, being able to integrate the user experience and what the user sees as part of that testing, I think is very important and can be applied at the cloud side and the network side.
That's a great point, Brian. The architecture that will need to be used to leverage both cloud, both hybrid as well as SaaS, along with the network, will be radically different. And companies will have to, and enterprise will have to rethink what needs to be done at which part of the network and which part of the application architecture in order to get the best value out of it. So absolutely spot on. We have time for one more question. How offloading device intelligence to the network will enable new immersive user experiences? Leandro, any thoughts on this?
Well, yes, we showed that already 2 years back in Mobile World Congress, where we just put the device as a client with a 5G network, boosting that efficiency and having these applications having the minimum processing time. So it was just literally a streaming, and the user experience was flawless and really good. I mean, within the last 2 years, I think we have been able to bring this also to have it in a market space. So, and I think that all these new solutions coming in will make it work this in a much better way. And this offloading of device intelligence to the network will enable VR, augmented reality. We have seen that in different use cases where people are owning and having different gadgets as a glass, right? You can see also virtual components, and also for learning. I mean, for people that do maintenance on a network and it takes like 3 months to do it, we can do it right now in 3 days. So that is ability in order to train people to do different things, but also to entertain in a different way people and get to the next level of experience, so to speak, right? And this is all possible by offloading the device intelligence to the network, right? Then we, with fixed wireless access is one way. We also the 5G to home is the other way. So there are different ways in order to create those use cases that the people are looking after.
Guys, we have a number of questions. I will go through them and then I'll share a few thoughts, and then I'll request for the panel to come in and share their thoughts. So the first question is, are you seeing use cases outside of the obvious industries, i.e. gaming and telcos, such as airlines, retail, hospitality, etc.? Or do you feel those are still several years away? In other words, is there any reason for an airline or retailer to start 5G testing? If so, what are those reasons? I'll share some thoughts, and then please, for the folks, for the panel, please come in and chime in. We're seeing quite a few use cases across the industries that you mentioned out here. For example, if you take retail, there is substantial transformation that is taking place within the retail environment around immersive experiences, around supply chain, around managing and understanding the user or the consumer when they are in the store. And they are one of the pioneers who are accessing mobile private networks or fixed wireless 5G to see how they can transform how they're engaging with the customers. With regards to airlines, if I zoom it up and I think about the travel industry, in fact, that industry is using 5G in a pretty interesting manner, right? There's a lot of work that's being done. If you take railways as an example, they're experimenting with slicing networks and seeing how they can use 5G for driving, looking at ways in which they can improve the drive in an autonomous manner, and also provide enhanced broadband to their users who are in the trains. So I think there's quite a bit of this innovation that's taking place across industry segments. When you mentioned telco in the question, the CSPs will play an important role in enabling this transformation. But over to you, Leandro, for any thoughts, and then for anyone else.
Yes, basically, this is happening now. It's not about to come. It's happening now. I mean, we have different use cases for airlines. We have different use cases for airports as well. We have different use cases for different industry players, for factories. And at the end of the day, any time that we in the production or in the communication, we see a benefit of having 5G, because either we do some cost savings or we can reach out to different use cases like virtual reality, augmented reality, better service, customer experience enhancement. We will see these use cases coming in all sectors of the industry, right? So I think it's already happening. And here is open information. We are also collaborating with Capgemini, and together we are also providing this type of service in order to digitalize, automate, and understand how 5G is improving the existing flows of information going from A to B and how to optimize it, right? So as an example.
Thank you, Leandro. Leandro, I'll pass the next question to you too. How will 5G impact backhaul networks? Will the market for 5G backhaul services be the same as for 4G?
Well, I mean, the biggest, the backhaul network, it will be impacted in a way that we will see more traffic coming in, and it needs to be also accommodated. Also, the mobile edge computing is a big thing that will enable and reduce the processing power of the end devices, right? We will have more the processing power very close to the device, but not on the device itself, and will enable also different use cases that we can see. So this has to come also with the backhaul and the rest of the core network in a way in order to be able to support all these use cases. But the mobile edge computing is the big thing that we will need to raise up in order to be able to provide those use cases with these new devices on 5G to the customers. Right?
Thank you, Leandro. On the next question, Brian, I will request you to answer this. The question seems there is a shift of intelligence from device to network. How does this affect network providers and device manufacturers?
Yeah, so while the network's getting more complicated and advanced, at HeadSpin, what we see is that the end user still comes at the network through a device. And so we feel that intelligence at the device level of what the end user actually sees and hears and perceives of the overall experience is more essential now than it's ever been. So that's why we put so much effort into giving the teams that are deploying technology access to the real edge devices that are interfacing with the network. I think it's a great question for the Ericsson team about the analytics that are coming out of sort of the network, but from an organization perspective, we feel like the device is more essential now, and understanding how the end user perceives the total experience on the device.
Yeah, thank you, Brian. So just to add to that, the intelligence is shifting. The question out here talks about device to network. What we're really seeing is that the intelligence is shifting to the edge, and there is a significant amount of edge compute that is being deployed so that the data could be processed and captured and processed at the edge. So from that perspective, if you look at how this affects the network providers, it becomes super important for the network providers to move away from just providing connectivity services to also providing applications and capabilities to businesses. So for example, providing capabilities around automation, providing capabilities like you mentioned around intelligence and understanding intelligence and insights. And then for that matter, what we have jointly created, providing capabilities by which if businesses are developing applications and driving intelligence at the edge, how can you improve the quality of experience? So there's a significant amount of that transformation that we have seen. We do expect that over 70% of the data will be captured and processed and analyzed at the edge. So I think there's a fundamental shift that's taking place. It'll require a completely new set of architecture for developers and engineers, right? Imagine that you're now working with state and stateless devices. You're working with the cloud, and you're working with hybrid infrastructure. You're working with different types of networks, and then you're working with different types of device endpoints, whether these are IoT or traditional screen or screenless devices. So there's a massive opportunity that's out here for whether you're a network provider or device provider to think about how you can move away from what you have traditionally been doing and position yourself for success and control in the next generation space. Leandro, any thoughts from you on this per Raj?
No, I think it's pretty much what you were saying. So it's you're spot on. I mean, basically, we will see the processing power going to the edge, and also devices with which very different capabilities, and in order to be able to handle different use cases, rely on the good mobile computing infrastructure from the network in order to support all these use cases. Exactly. Yeah.
Thank you. The fourth point, this is from Sandra saying, can I deploy in Latin America with both Ericsson and HeadSpin? We'll be delighted to work with you and see how we can take this forward. Yeah, please reach out to Rajiv Ranjan. You see the link out here on the slide, and then we'll take it forward from there. The next question, has Ericsson or HeadSpin worked with AR or VR? So I'll pass this on to Brian and Leandro to answer the question.
From the HeadSpin side, we've done some work with Oculus, a little bit of prototype work. What's really great is that the Oculus does show up on the HeadSpin platform. Beyond that, though, we haven't engaged deeply with a partner yet on an AR or VR use case. Would love to hear the thoughts from the Ericsson team.
Yeah, absolutely. Yes, of course we have, and we have been for a couple of years now preparing also the test beds for the future in order to accommodate tests and verified different AR, VRs, even thinking about holoportation and all these new use cases that are coming with different customers that I cannot name. But yes, we are definitely looking and preparing for all and testing basically all these new solutions for AR and VR, and we have also together with different operators also run different in the factories and not in the factories, also different use cases in order to train their own people in order to shorten the training time from 3 months till 1 week or 3 weeks in order to secure that they have a better improvement in order to do the same work in a reduced time and get the competence up and running, right? So with this augmented reality and virtual reality type of capabilities, as an example.
I wanted to mention one feature that we haven't totally shown here, which is we have an additional node, which is called a media platform node. This is something that is a little bit outside the Ericsson lab. We just haven't fully integrated that yet, but it involves a screen where you can, through an API, show images on the screen. And we found that very successful for camera testing. So if there's a camera situation, for example, in the know your customer space in finance, this has been a very successful solution. So that's one other capability of HeadSpin I'd like to put out there.
Thank you, Brian. Thank you very much to all who attended the session, and thanks to the presenters. You can see we're presenting at Mobile World Congress. If you all are there, please reach out to us, come to our booth, see our platform, and we look forward to hearing from you. Thank you. Bye.
Thank you so much. Bye-bye.
Thank you.